Since Satoshi Nakamoto released the first version of Bitcoin in early 2009, digital currencies and blockchain technology have been the site of frenzied innovation, excitement, and speculation. In addition to Bitcoin itself, hundreds of competing and complementary blockchains and currencies have come and gone. In this tutorial, we'll be looking at Ethereum, which is the second most popular and widely used cryptocurrency after Bitcoin. Ethereum's main innovation is to provide a Turing-complete environment for on-chain computation, which means that we can run code on the blockchain. This opens up an immense field of possibilities for creating decentralized finance, DeFi platforms, which can then act as open alternatives to traditional financial services such as loans, investments, insurance, and the sale of artworks. In this tutorial, we will be building a simple escrow smart contract, which will include deploying our own non-fungible token, NFT. I will be following this guide on replit.com. So that's where you can copy and paste the code described in this video. The link is in the description below. By the end of this tutorial, you will have experience with developing Ethereum smart contracts using the Solidity programming language, know the basics of deploying contracts to a blockchain and interacting with them, and lastly, have an understanding of some of the key considerations for secure blockchain development. Now let's get into it. To get started, we need two things, and these are a Solidity repo and a browser wallet. To create the Solidity repo, log into Replit or create an account if you haven't already. I already have an account, so I'm just going to click on login, then put in the username and password, and then click on login. Once logged in, let's create a Solidity repo. So click on create at the top left corner or this plus sign at the top right corner to create the new repo. On the dialog that comes up, under template, search for Solidity and then select it. And then we have to give the repo a title. I'm going to call this Escrow. And then click on create repo to create the repo. The Solidity starter repo works a little differently from the other repos you may have used in the past. Rather than running our repo every time we want to test out a new piece of code, we can run our repo once to start it up. It will then automatically reload when changes are made to our Solidity code in the contract.so file. I'm just going to run it with the default code. The Solidity starter repo comes with a friendly web interface, which is built using the Web3 Ethereum JavaScript API. We will use this interface to deploy and interact with our contracts. We will also deploy Replit's testnet, which is a custom version of the Ethereum blockchain managed by Replit and optimized for testing. Now we need to install a browser wallet. We need a browser-based Web3 wallet to interact with the Replit testnet and our deployed contracts. MetaMask is a popular and feature-rich wallet implemented as a web extension. You can install it from the MetaMask download page, which is metamask.io/download. Just make sure that you are using a supported browser that is either Chrome, Firefox, Brave, or the Edge browser. So just go to the MetaMask download page. Make sure that your browser is selected here, and then click on Install MetaMask for Chrome. Since I am on Chrome, this will open up the Chrome Web Store where I have to click on Add to Chrome. On the dialog that pops up, click the Add Extension button. As you can see, it's being added to Chrome. Once it's added, the Add to Chrome button changes to Remove from Chrome, and it also opens up the MetaMask Get Started page. So I'm just going to close the Chrome Web Store as well as the MetaMask download page, and then click on Get Started to get started setting up the wallet. If you already have a wallet, you can click here on Import Wallet. I don't have a wallet, so I'll click on Create a Wallet. I will accept sending usage data, so I'll click on I agree. And then you have to create a password. So just put in a strong password and then confirm it. And then also confirm to reading the terms of use. And then click on Create. The next thing you have to do is to secure your wallet. So click on Next to get your secret recovery phrase. Click here to review the secret words, copy them and store them in order somewhere safe. This secret phrase is your wallet's private key and must be kept safe and secret. If you lose this phrase, you will not be able to access your wallet, and if somebody else finds it, they will be able to access your wallet. Now click on Next to confirm your secret recovery phrase. Now input the words in the order they were displayed to you. And then click on Confirm. If everything is fine, you get this congratulations page and also tips on storing it safely, such as having a backup and never sharing it with anyone. And then you can click on All Done. If you are already using MetaMask, we recommend creating a new account for testing with Replit. You can do this from the account menu, which appears when you click on the account avatar on the top right-hand corner. And then clicking on Create Account to create the account for testing. Now that we've got our repo and wallet set up, we can now start developing. We will be writing contracts, which are the basic building blocks of Ethereum programs. An individual contract can have state variables and functions and can inherit from multiple other contracts. Contracts in Solidity are equivalent to classes in a language like Python or Java. Contracts on Ethereum and Ethereum-based networks, such as the Replit testnet and Binance Chain, are compiled to bytecode, which runs on the Ethereum virtual machine EVM. This is similar to how Java code compiles to bytecode for the Java virtual machine JVM. A list of opcodes for EVM is provided here. Many of the opcodes dealing with arithmetic and logical operations should be familiar if you've worked with any kind of assembly before. The EVM also has opcodes for blockchain-specific operations, such as getting information about the current block or chain. An additional consideration unique to blockchain development is that each opcode has an associated price, which is listed here. Users of smart contracts pay a fee, known as gas, to invoke state-changing functions. This fee is determined by the opcodes used, and so it is in the interest of the developers to keep their code as simple as possible. Solidity, which we will be using below, is the most popular language for developing smart contracts on Ethereum. Alternatives such as Viper exist, but they are not as widely used. Let me just close these pages. Before we jump into the code, let's make sure we have a plan for what we are going to build. An escrow is a contractual agreement in which a third party receives money from one party and pays it to another party after a certain condition has been met. In traditional finance, this third party needs to be a trusted individual or organization such as a bank, but in DeFi, it can be a smart contract. We will build a simple escrow protocol that holds funds until a specified duration has passed. This could be used to give a friend some Ethereum for their birthday or to save money for a specific occasion. Our escrow protocol will consist of two contracts. Escrow, which will provide the end user interface for escrowing and redeeming funds. This contract will also store all the escrowed funds. Escrow NFT, which will store all the details of individual escrows as NFTs. This will allow users to transfer immature escrows between one another. While the most famous use of NFTs involves buying and selling artworks and other collectibles on marketplaces like OpenSea, we can use them for all kinds of other purposes, such as to represent escrows. We are going to start coding with the escrow NFT contract, so open the contract.sol file if it is not already opened. I'm just going to increase the font size here, and then delete all the file contents, and add the following. This first line of our contract is the license identifier. Smart contracts are usually open source, and reuse of other projects' code is common in DeFi, so it's a good idea to include a license that indicates how you would like others to use or not to use your code. Supported licenses are listed here, Next, we define the version of Solidity that we are using. In this case, we are using any version newer than 0.8.2 up to 0.9.0. Solidity is an evolving language and it often introduces breaking changes, so our code may not compile under older or newer versions of the language. Following the pragma statement, we have to import some contracts from the OpenZeppelin contract library. This library includes inheritable-based contracts for a wide variety of common smart contract development needs, including base implementations of Ethereum token standards. The Ethereum token standard for NFTs is ERC 721. So rather than implementing it ourselves, we can import and use OpenZeppelin's version. Note that while OpenZeppelin has a base ERC 721 contract, we will use a couple of extensions. So just paste the imports and let's go over them. Let me make this a bit wider. OpenZeppelin's ownable contract allows us to enforce access control on sensitive functionality. ERC 721 bannable allows us to destroy NFTs that have been redeemed. ERC 721 enumerable allows us to list which NFTs belong to which owners. Both these extension contracts, that is ERC 721 bannable and ERC 721 enumerable, inherit from ERC 721. Now let's put in the contract definition line. Solidity supports multiple inheritance, so the contract definition uses all of our imports. In the contract body, we will define a few state variables. The first one is token counter. This will provide us with unique incrementing IDs for tokens as they are minted. Next up is amount and mature time. These mappings will store data for each token we mint. Note the use of unsigned integer uint256 as the type for these values. We use it because most of the values we deal with in Solidity programs are monetary, so unsigned integers help us to avoid storing negative numbers. In versions of Solidity prior to 0.8.0, these sometimes led to dangerous overflows, but overflow protection is now built into the language. We also don't need to initialize any of these variables, as Solidity will automatically set uninitialized variables to 0. Now we need to add the constructor method. There should be no space here. This constructor method calls a parent constructor to define our NFT's name and symbol or stock ticker. Now we need to define a mint function so that we can create NFTs. We will start with the function definition, which we will add just below the body of the constructor. Let me just extend here so that it fits on one line. We are defining a function named mint, which takes 3 arguments. So we've got underscore recipient, which is of type address. This is the address where we will send the NFT to. This can be a user's wallet or another contract. Then we've got underscore amount, which is of type uint256. This is the amount of ether escrowed by this NFT. And then lastly, we've got underscore mature time, which is also of type uint256. This is the time represented as a Unix timestamp at which the NFT's funds will be redeemable. It is a public function, which means that it can be called by both external users and by other functions in this contract, or any contracts that inherit from it. Solidity provides granular function and visibility options, which are explained here. Finally, only owner refers to a modifier defined in ownable. Modifiers are generally used to restrict functions for purposes of access control or state logic. This modifier will ensure that only the owner of the NFT contract is allowed to mint NFTs. This mint function will return a single uint256, which is the numeric ID of the minted NFT. Now that we have read and understood the function definition, let's add the function body. Here we use ERC721's internal mint function to mint a new token to the recipient with the current value of token counter as its ID. We then have to set the amount and mature time mappings for our new token. So I'm just going to put a comment here, set values, and then set the amount. And then set the mature time. Then we need to increment the counter. And then return the ID of our token. Next, we need to make a function that will return the details of a given token. So add the following code below the body of the mint function. We declare this as a view function. This declaration asserts that the function does not modify state and thus its invocation does not need to be recorded on-chain. This means that it will be callable for free. Our function body starts with the require statement. This is an error handling function in Solidity. If the condition in the first argument is not met, the current transaction will revert. That is, it will undo all the previous actions, and the error message in the second argument will be displayed. Lastly, we have the return statement. If the function is invoked with an existing token ID, it will return two uint256 values, the amount and the mature time for that ID. Note the syntax for multiple return. We are almost done with our NFT contract, but before we move on, we need to add a few boilerplate functions. Add the following code below the body of your token details function. This function will return the contract's address. This will make it easier to work with in the Replit web interface. Add two more functions. These two functions resolve ambiguities introduced by Solidity's multiple inheritance. Because we are using two different ERC721 extensions, the base ERC721 contract is inherited twice with different functions added and overridden. To resolve the compiler's confusion, we specify that versions of _before token transfer and supports interface provided by ERC721 enumerable should be preferred. We are done with the Escrow NFT contract, and now we need to create our Escrow contract. This escrow contract will act as an interface for creating and redeeming escrows. Add the following contract block to the bottom of contract.so below the escrow NFT contract. So just come to the end of the escrow NFT contract and then paste it here. This contract inherits from ownable, and we define two state variables. Escrow NFT is the instance of the escrow NFT contract that our escrow contract will use. Initialized. This variable will help us to implement the initializable design pattern. We also defined a number of events. Events provide a user-friendly form of logging on the blockchain and are commonly used by DApps, decentralized apps, that is, web front ends for smart contracts. It's considered best practice to emit events whenever a state change is made. So we've defined events for our contract's three state changing actions: creation of escrow NFTs, redeeming of escrowed funds, and initialization of the contract. Let's implement the initialization now. Add the following code below your event definitions. This is a custom modifier, is initialized, which will revert if initialized is false. If initialized is true, the function we apply this will execute at underscore. Next, let's define our initialize function, which takes a single argument, the address of the escrow NFT contract to use. We've given this function external visibility, so it can only be called by an external user. We have also applied the only owner modifier, so only the contract's owner can initialize it. In the function body, we ensure that the contract is not already initialized. And then we initialize our escrow NFT state variable. Lastly, set initialized to true and emit an event. Now we need a function that allows us to create escrow NFTs. So add the following code below the initialize function. Our escrow ETH function is payable, which means it can receive Ether and it uses the initialized modifier. It takes two arguments, a recipient address and an escrow duration specified in seconds. In the function body, we ensure that the recipient is not the zero address to prevent users from accidentally minting NFTs without specifying the receiver. We also ensure that the amount of Ether to be escrowed that is accessible from message.value is greater than 0. We then set the amount and mature time values for our NFT using block.timestamp to get the current time approximately. These values are then provided to escrow NFT.mint, which will mint our NFT to the specified recipient. Finally, we emit an event using message.sender to retrieve the address of the user who called the function. Now that we can create escrow NFTs, we need a way for the recipient to redeem the funds in a matured NFT. Let's create a function for that below the definition of our escrow ETH function. Let me just align these closing brackets. And then under the escrow ETH function, we paste the code for the redeem ETH from escrow function. Our redemption function first checks whether message.sender is the owner of the token to prevent users from attempting to redeem tokens they don't own. It then retrieves the amount and mature time for the specified token ID and checks whether the mature time has passed. If the token is owned by message.sender and its mature time has passed, it is banned using the ban function from ERC721 bannable. This destroys the token, ensuring that it cannot be redeemed again. Once the token is destroyed, we transfer its underlying Ether to message.sender. As the creator of the escrow NFT originally paid this amount of Ether into the contract, it should still be available. There are a few different ways of sending Ether in Solidity. You can use transfer, send, or call. Using call is the best one. Call returns two values, but we only want the first one, so we leave out the second variable declaration in our multiple return syntax. If the Ether transfer fails, we revert, undoing the destruction of the token. Otherwise, we emit an event to record the escrow redemption. Our contract now does the main things it needs to, but we can make some improvements. For example, rather than requiring users to specify the ID of the token that they want to redeem, we can create a function that redeems all matured tokens in their possession. Let's do this now by adding a new function beneath the definition of redeem ETH from escrow. So just create a new line here and then paste the code. We now have a redeem or available ETH function. We start by querying escrow NFT.balanceOff to find out the number of escrow NFT tokens message.sender owns. If they own none, we revert. We then create a variable named total amount and loop through the user's NFTs. We can get the ID for each one using token of owner by index, a function defined in ERC721 enumerable. We then retrieve the amount and mature time for the token using escrow NFT.token details. If a given token's mature time has passed, we ban it and add its value to total amount. Once the for loop is completed, we check whether total amount is greater than 0 and revert if it isn't. We then send the total amount in Ether to message.sender. If the Ether transfer fails, we revert. Otherwise, we emit an event to record the escrow redemption. At this point, you may wonder why we didn't just loop through the user's NFTs and code redeem on each one to avoid repeating code. While this would make our code simpler to read, it would lead to a lot of extra checks and transfers, which would make this function more expensive for users to call. When developing smart contracts, keeping the cost of each function invocation to a minimum is paramount. Let's add one more function before we deploy our contracts. We are adding the contract address function below the definition of redeem or available ETH. You should recognize contract address from escrow NFT above. Here's contract address in Escrow NFT. And with that, our code is complete. Now that we've written our contracts, it's time to deploy them to the Replit testnet and test them out. We will use our Repo's web interface to do this. This is the web interface. If your repo is not running, please run it, and then once all the dependencies are installed, you should see the Replit Ethereum web interface in your repo's browser. This is a bit small for me, so I'm just going to open it in a new tab. Click on Connect Wallet to connect your MetaMask wallet to the web interface. Click on Next on the MetaMask notification, and then click on Connect. Now switch to the Replit testnet by clicking on Switch to a test network via MetaMask. And then click on Approve. And then click on Switch Network. As you can see, we are now on the Replit testnet. Then click on the link that says Get 1 ETH for testing. The balance is updated, so I can now deploy the contracts. Select Escrow from this drop-down and then click on Deploy. Just approve the MetaMask notification. As you can see, we now have Escrow under deployed contracts. Now let's do the same for Escrow NFT. So just click on the drop down and then search for Escrow NFT. And then click on Deploy. Confirm it. Once these contracts have been deployed, they'll show up as expandable boxes below deployed contracts. Just expand both and take a look at the different functions available. Before we can use either of these contracts, we need to do some setup. First, let's initialize Escrow. In Escrow NFT, run the function contact address. Then click on the output to copy it to your clipboard. Then in Escrow, find the Initialize function. And then paste the contents of your clipboard into the value for _escrow NFT address. Now run the Initialize function and confirm the MetaMask notification. Our Escrow contract is now initialized and linked to Escrow NFT. But before we can use it, there is an additional complication. You'll recall that we added the only owner modifier to the mint function in Escrow NFT. When a contract that inherits from Ownable is deployed, its owner is set to the address that deployed it, which will be your wallet address. But we need it to be owned by Escrow so that Escrow ETH can call mint. Luckily, Ownable provides functionality for transferring ownership, so we transfer Escrow NFT to Escrow in the following steps. In Escrow, run the view function contract address. Click on the output to copy it to your clipboard. Then go to Escrow NFT and find the transfer ownership function. Then paste the contents of your clipboard into the value new owner. Then run the transfer ownership function and confirm the MetaMask pop-up. Now Escrow owns Escrow NFT and our system will work. Let's test it out by doing the following. Find the Escrow ETH function in Escrow. Now specify your own address, a short duration, I'm going to put 60 seconds, and a small amount of Ether. Then run the Escrow ETH function and approve the MetaMask notification. If you attempt to claim your escrowed Ether using either of the redemption functions in Escrow before the duration has passed, the transaction should fail with the expected error message. I'm just going to select redeem all available ETH and run it. As you can see, the message is execution reverted, no escrow NFTs to redeem. So now I'm just going to wait for the duration to pass. It's over 60 seconds now. I'm going to run redeem all available ETH again. And again it failed. Both redemption functions call escrow NFTs burn function to burn tokens. This is an access controlled function available only to the token owner and addresses approved by the token owner. If this weren't the case, anyone could burn any token just by calling the function. To allow Escrow to burn our NFT, we need to give it approval. We can do this in the following steps. Copy the address from Escrow's contract address function to output. Then in Escrow NFT, find the set approval for all function. Paste in the address as the value for operator and specify true as the value for approved. Then run the set approval for all function and confirm the MetaMask notification. Once approval is set, you should be able to successfully redeem the escrowed Ether from your mature tokens. We have written our escrow system as a way to learn about Solidity development and interacting with smart contracts on the blockchain. To facilitate these outcomes, our contracts make use of a design that is partially insecure and would not be recommended in practice. A key part of earning user trust as a smart contract developer is to ensure that you have minimum control over the contracts you deploy. That's why, for example, we designed the Initialize function in Escrow to only be callable once. If a contract has a large number of privileged functions that make significant changes to its state and behavior, there is a risk that the owner or a hacker who manages to compromise the owner's wallet will use these functions to steal user funds. An unscrupulous developer could create a malicious version of our Escrow protocol by doing the following. After deploying Escrow NFT, but before transferring its ownership, they could call Mint to create an Escrow token with an amount of 100. They could then transfer Escrow NFT's ownership to Escrow and wait for users to start paying Ether to Escrow in order to create tokens. Once Escrow has a balance of 100 Ether or more, the developer could redeem their token, successfully stealing all user funds. Redemption of any subsequent Escrow tokens would fail as the Escrow contract would contain insufficient funds. While the evidence of all this happening would be visible on the blockchain through events, users may not want or easily be able to look at that information before using the protocol. Another less serious consideration is that block.timestamp is not always accurate. As this value is derived from when Ethereum miners report it, it can be manipulated slightly. This will have a negligible effect on escrow periods of multiple days, weeks, or months, but could affect short escrow periods quite significantly. Now that you've got your feet wet with Solidity development, here are some ideas for further development. Modify the architecture of the protocol to make it impossible to create a malicious version in the manner described above. Create a view function in Escrow that tells the user how much Ether is available for redemption. Determine whether the user has approved Escrow before attempting to burn tokens. Add a nice error message if they haven't. Create an ERC20 token and allow users to escrow it instead of Ether. see if you can rewrite any of the contract functions to use less gas.